Okay, so for my final exam review, I'm going to go kind of quickly through these problems because there's kind of a lot of them. And so please understand that if I go quick, please just pause things. Or you could change the speed on the video. It's fine. I just am concerned that I can actually have enough time to produce that many of them this quickly. So anyway, let's take a look at this, the first five or so questions, but I got a phone call that messed up my video in the last one, so I'd already started, but here we go. This asked me to simplify -1 plus 5i. So I wrote -1 plus 5i twice, and I just did a distribution, which some people like to call FOIL. I went ahead and I did the first piece, then I went to this outside, and then here, and then last. And then remember that I squared is -1. That's really a very old Algebra 2 question, so I think we should be okay. So moving to the next piece of this story, it's asking us to express the answer to this. Now, keep in mind, this is some kind of a parabola. What I don't know is where the x-axis is. It's probably something like that. So I would want to know where that's underneath the axis, which is somewhere in here between those two roots. The thing that we got to figure out is what are those factors that make it work. So some people like the boxes, some people like diamonds. I personally usually just start and think about what they possibly could be. And so based on these two coefficients being relatively small, I'm going to guess that I could probably get away with a 4x and a 3x. Now, one of the reasons I know it can't be a 6x and a 2x is because 6x and 2x are both even numbers. And if I use two even numbers, there's no way I could put it together and get an odd. So it either has to be a 1 and a 12 or a 4 and a 3. And so if I put, let's see, if I put the one here, let's see. If I put the 3 here and the 1 here, I could have 12x squareds. I could have 4 and 9, 4x and 9x, and I could make a 4 and a 9 into a -5 if I made that part positive. So what I want to do is I want to select the number -1/3 and the number 3/4. Those are my two roots. These are the place where 0 happens. And keep in mind in this story, I said or equal to, so we like it. Remember, parabolas go like this. They're up on the sides and down in the middle. So I'm wondering when it's true. So that would happen where x is an element of values between -1/3 and 3/4. And notice that I made square brackets there, and those square brackets are indicative of the fact that you can actually touch both sides. Now, sometimes you have inequalities where we can solve them easily. And sometimes you get some that are a little bit tougher to solve. So this is a little cubic equation. So you didn't have to sit there and watch me type. I typed the equation in already, but I didn't really do a lot. And I wanted to find out when this cubic equation is graphed, which could be something that looks like this, or it could be something that looks like this. I don't really know. It's one of those two. So let's go ahead and let's do like a zoom 6. I don't really know what a smart window is. But oh, there it is. It looks something like that. I don't like that window very much because there's a lot of blank spot over here and up here. So I'm going to go ahead and only go from maybe -4 to 4. And it looks like there's not a lot going on. So I feel like a little smaller window is smarter. So it looks about like this. And I want to know, when is the graph, let's see, according to this, below the x-axis. So it looks like there's a little region in here and a region right there. So I need to find out what this value is A, this value right here is B, and that value right there. So I'm going to be below the axis from -infinity to A. And then I'm also going to be below the axis from B to C. So all I need to do is use my calculator to calculate. So second calculate. I'm going to find the 0, which is number 2, and I'm going to move the cursor to the left. Remember, it always asks to go left first, enter, go to the right second, and hit enter twice. So that happened at -1. Well, I did not expect that. From -infinity until 1. I really honestly didn't expect that to be a nice answer. Guess I should have checked. My second value of the 0 is over here. Remember, I go to the left of the answer and go to the right of the answer. And that happens until 0.226. And the last place that 0 happens, we're going to do it one more time, is from, let's go to the left and then again to the right, till 0.63. I guess we could go 0.631. So those are those regions where the graph is below the axis. So this portion is the one that is right here. And of course, we've got this region over here, which is this portion that's underneath the axis right there. Okay. Now, moving on to number 4, we have a rational equation, which is actually timely. We've been studying that recently, except this one is just a much nicer, simpler problem. So what I'm going to do is a little fraction buster, and I'm going to multiply each piece by 12. Because 4 goes into 12 3 times. So I have 3 of these 5 plus 3 guys. 6 goes into 12 twice. So I have 2 of these 2x plus 1 guys. But keep in mind, there's still a minus in the middle, and that's why I asked this question. Because when I distribute this, a lot of people forget about that minus there. And parentheses matter, and that's going to be equal to 7 times 12. Nothing cancels. I'm looking at 84. So 15x and 9 minus 4x minus 2. Let's see. So I have 11 x's. 9 minus 2 is 7. We're kind of getting there. Let's go ahead and add 7 to both sides. So that'd be 11x equals 84 minus 7 is 77. Oh my goodness, I got really lucky. And I got x equals 7. Now, I'm personally a fan of checking my answers, so I'm going to go ahead and do that because that honestly worried me. I thought this problem was going to be harder. So let's go 5 times 7 plus 3 divided by 4 minus 2 times 7 plus 1 divided by 6. And what do you know? I did get the answer 7. That was a little surprising. I was thinking it was going to be kind of an ugly answer. Now, for part B on this problem, whenever you have an absolute value, you want to remember that an absolute value is like a V, and I want to know when is that V equal to 15. So there's going to be 2 places like that where that happens. So the one over here is going to happen where 5x minus 7 is positive 15. And keep in mind it had a positive slope. Or the other answer was where 5x minus 7 is negative 15. And that doesn't really look like that because these are clearly not parallel lines, but it's because the reality is what you're really supposed to do is take the original equation that you had, which is 5x minus 7, and make it negative 5x plus 7 and make it 15. Most teachers are not going to ever have you write it in the opposite version and leave the 15 alone. We multiply both sides by a negative. And so that's just kind of the smart way to do it. So if we add 7 to both sides, we're going to get negative 8/5. Or over here, if I add 7 to both sides, I get 22/5. Now again, as always, I love to check my answers. So if I took 5 times, let's see, 5 times 22/5 minus 7, I got the answer 15. And when I took the absolute value of that, I did in fact get 15. But if I try to plug in the answer negative 8/5, 5 times negative 8/5 minus 7 gives me negative 15. And that absolute value, of course, is also positive 15. Okay, we'll try to get through maybe 2 more. Okay, now this says by the method of your choice. And to be honest, I feel like the method of my choice on this one is not the one I normally pick. I think I'm going to pick the quadratic formula. So we want to remember that that quadratic is x equals opposite b plus or minus b squared minus 4ac over 2a. Okay, so the opposite of b would be 7. B squared again would be 49. Minus 4 times a times c is 4 times 4 times negative 1 would be negative 16. All over 2 times 1. So it looks like I've got 7 on top, 8 on the bottom, and this would be the square root of 65, which is kind of an ugly answer, and I'm just going to leave it alone. That would be plenty good. If you chose to do completing the square, you will get the same answer. So let's just keep going. Maybe we'll see if we can finish this up a little bit. One of the rules of exponents is that powers of powers multiply. So see, we have x to the 4th cubed would be x to the 12th. Y to the minus 2 would be y to the minus 6 because they multiply. This y on top would be y to the negative 10. And this one would be x to the positive 8. Now, I went through and I actually did the easiest problems first. The problem that a lot of people have is with this one, because if you took 3 to the negative 2, because that's what it says, a lot of people struggle with that because a negative exponent is really a reciprocal. That means this 3 to the 2 doesn't belong there. It belongs here. It also means that this x is fine, but this y has a minus exponent, so I'm going to bring it down, and this one has a negative exponent, so I'm going to bring it up. So remember, negative exponents are simply a reciprocal, so my final answer is going to have 9 in the bottom. If I had 8 x's on the top, but 12 on the bottom, there's 4 additional x's in the denominator, and the same thing right here. And there literally is nothing left on top, which means it's going to be a 1 over that value. So we should be looking pretty good. So next little thing is I asked you to find the slope of these two lines. So if we're looking for the slope, we want to see if we could get x by itself, or y, excuse me, by itself. So if I divided everybody by -2, I would say that my slope is 3/2. This problem over here, I kind of messed with you a little bit. I want to get y by itself, but nothing ever says that y has to be on the left side. It could also be on the right side. So again, if I divide by 4, then that slope is 3/4. Now, the last little piece is coming up with a nice new equation that is both parallel and perpendicular. So my favorite is the point slope form of a line. It's awesome, but this is what we call standard form, and there are a lot of people that really like standard form too. So what we're going to do is we're going to start with writing y minus the y value. I'm going to write x minus the x value, so subtracting a -5 makes it a +5, and my slope is 3/2 originally, so a parallel line would also have a slope of 3/2. This is a perfectly valid equation of a line, and same way over here, y minus the y value, x minus the x value, but if I'd like it to be perpendicular, I would like it to be the opposite and reciprocal. So the reciprocal part is 4/3, and since this is a positive, the opposite is negative. So these are both really good answers, but I am going to go ahead and go a little bit further, and let's say I wanted to go to slope-intercept. But I'm not going to do it on both. I'll just choose one. So I'm going to do this guy right here. So if I were to distribute 3/2 times x and 3/2 times 5, the only thing I have left to do is I need to add 2 in the form of 4/2 to both sides. Remember, 2 is 4/2. So if I added 2 to both sides, this would cancel out. 3/2 x, 15/2 plus 4/2 is 19/2. So this is a good answer. So is this. Notice it just says find an equation. So I didn't specify. The last thing is if I wanted to be in standard form, I wouldn't want any fractions. So I would multiply everybody by 2 and move things around so the x is first and the y is second. So not too bad. So hopefully that was an okay rendition there, and I will see you for the next page. Bye-bye. See you back in class. Have a good one.